Hello, everyone. All right, welcome. This is the name of our panel here, Transit Performance Dashboards and Visual Potpourri. That might be a precedent for the National Academies to have potpourri in the name of a panel. So right now, we are scheduled to have 3 speakers. I don't think Rue and Kevin, are you here? All right, we're down to 1 speaker. I don't even know who they are. They didn't reply to the email, so I don't know what happened. So Will tells me he can go on for an hour. What I think we'll do is, so I told the speakers that they would get 18 minutes. Will, what do you think about this? We'll stop you at 18 minutes, and then we can have a discussion, and if people are interested in a specific thing, then you can just take all the time in the world to go back and have a discussion by showing them more information. Does that sound like a good plan? So let me introduce myself. So I'm Michael Shade. I work for CAT Lab over at the University of Maryland. That's the Center for Advanced Transportation Technology. And I actually know Will because I also, in my spare time, I run a meetup called Transportation Techies for software developers who are transit nerds or bike nerds and just do things for fun or just want to share the projects that they've worked on. And this is based in DC, but Will was kind enough a few months ago to come down from New York City and share his work with us. So I know that you're in for a treat because he does great work. And I also know he does great work because I follow him on Twitter, which is Geary, and I recommend that you all check it out as well. And while you're on Twitter, there's actually a Twitter account for the TRB Transportation Data Visualization Committee, and that is TRBVIS. So if you @ that in one of, does anyone here even use Twitter? Anyone? Okay. So if you want to include that, if you want a live tweet, and I'm there over at MVS202 in the meetup. If you're interested, I think it's interesting, even if you're not in DC, that's Techies DC. So with that, here's Will's intro. He's a data scientist at Revel Transit, an electric moped sharing service operating in New York City, Washington, D.C., and Austin, Texas, basically the 3 hotspots, hipster hotspots of America. That was my ad lib. Will's work includes transportation demand modeling, spatial analysis, and data visualization to support expansion planning, fleet operations, and customer support. Will holds an MS in data science from Columbia University and bachelor degrees in philosophy and economics from Duke University. So, Will, thank you so much for coming down from New York City and joining us.
Yep. Thanks, everyone, for being here. So thanks for the intro, Michael. My name is Will. I'm excited to talk about a tool that I built called Wayfinder3D, which is a free and open source tool for visually comparing route alternatives by travel mode. As Michael mentioned, I'm a data scientist at Revel. We're an electric moped sharing company. I won't give you a long pitch, but we have very simple pricing scheme. We take safety very seriously. Everyone must be 21 years older, have a valid driver's license, and wear a helmet, of which we provide 2. And as Michael mentioned, we're in DC, Brooklyn, Queens, and Austin. But what brings me to the conference today is a project that I built last year called Wayfinder3D. So I live in New York. I commute primarily by subway, bike, and bus. And I find myself often in the position of trying to convince people that it's faster to bike somewhere than to drive somewhere. So I got tired of having to do this without any kind of visual props, so I made a tool to enable me to tell a story to support my arguments. So this is the output of Wayfinder3D. It visualizes from origin to destination any number of 4 modes: walking, driving, cycling, and transit, as a race between the 3 modes, so that you can see what route is recommended and which mode wins. So here we're seeing a trip that I have modeled from Midtown Manhattan to downtown Brooklyn. Driving is the yellow route, cycling is green, and transit is blue. And I think the bike wins in this case. Oh no, subway wins. Subway, bike, and then car. So this is all just the same information that Google Maps provides when you do routing. I'm not doing anything fancy or in addition to that. I'm just hitting their API. But I think what's powerful here is sort of the intuitive visual that can be helpful in storytelling. So I'll show a few more examples that I've made, and then some examples of how other people have used this and then I'll talk about how it works. So here I was considering, okay, should I take a train or drive from New York to DC? So I loaded up transit versus driving and transit wins. And similar, here's Washington, DC to Baltimore. So sort of like one of my hopes of a potential use case for this would be like a DOT sort of tweeting out a video saying like, hey, consider taking the bus or the train from A to B. It's actually faster than driving, and then showing sort of this as like visual proof. Here's sort of a random one from Copenhagen to Malmö, Sweden, where transit beats the car. I tend to choose examples where transit wins. There are tons where the car wins that I just maybe share at a lesser rate, so there is some confirmation bias going on here for sure. But people seem to really enjoy the visual. I have put it on Twitter a few times, and it gets like tens of thousands of views and engagements and whatnot. Here's one that I made on National Bike to Work Day, sort of showcasing that the bicycle is not only faster than driving, but also has this wonderful route through Central Park. And people seem to really eat it up. Honestly, more than I expected, because again, this is all the same info that if you were to do your own routing on Google Maps, they would provide the same exact info, they just don't visualize it this way. So a few examples of people using Wayfinder3D in ways that I found exciting. Here's someone named Geary Lopez showing car versus public transit in Barcelona. He translated it to Spanish, which is awesome. And here he's saying that connection routes between the metropolitan area and Barcelona, public transportation is better than many people think. For this reason, it is used in most journeys versus private vehicle. And he did a couple other of these. Here he says, in the urban environment where there is a bike lane, the bicycle is shown as the fastest means of transport. So he's showing bike beating car in this case. And I found these really exciting because these were like exactly the type of stories that I was interested in telling and was interested in building a tool to facilitate others telling. So just at a high level, how this is working. So it's a Python and JavaScript tool. It's open source and free on GitHub. I'm pinging the Google Maps directions API, giving it a start time, an origin, and a destination, and it returns back the top route recommendations, as well as the duration of those routes, the ETA. So Wayfinder3D is primarily a Python script that parses this data, and then generates a web application using Cesium, which is a JavaScript library for 3D globes. Has anyone heard of Cesium or used it before? It's pretty cool. It's kind of like Google Earth, but the entire thing is open source, and you can build your own custom applications with it. And I'll do a quick demo at the end so you can see how this works from the user's end. This generated a number of comments on Twitter that I found pretty interesting. This one in particular, someone says, could you supplement that graphic with a cost per distance / fuel consumption / emissions graphic and do one for London? And sometimes it can be frustrating when strangers ask you to do work for free, but also it can be illuminating to understand what types of things they would like to see. So I've been playing with this. In particular, the emissions graphic I think is really interesting because emissions are invisible. We don't see what we're doing, what emissions we're creating as we make our choices in how to commute, move around our towns and cities. So I do wonder like how powerful it could be if when doing a sort of like routing, if you pull out Google Maps or Google Maps on your computer and route yourself from A to B, how powerful it could be if we were to visually sort of show people the emissions associated with one particular mode versus another. So that's a direction that I would like to take this, is to have sort of this kind of like cloud type of metaphor that is commensurate with how much emissions are associated with various modes. And then thinking about cost is really interesting. I mean, you could have like a stacked bar that's sort of showing the cost. I was also thinking you could have like coins, kind of like a Mario Kart type of video game, and like, you know, ding, 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 ding as you ride along the way. But seriously, I do think that routing is an opportunity to influence people's travel behaviors. And just in the context of climate crisis, it seems like one that we need to be taking seriously. So because I do have some extra time today, I'll talk a bit about some thoughts on how to describe motion with data. I have an acronym for this that is LOVE, latitude, longitude, elevation, timestamp. And I think what cesium has done is really interesting. Oftentimes, spatial temporal data sets will look like this, where there's start times and positions, end times and positions, and then maybe some information about that trip in addition to that. What cesium has done is create a JSON standard that they call CZML, and the concept is basically for one moving object in space, it's just a long list of timestamp, longitude, latitude, elevation. So you can imagine as you're moving throughout your day, you're generating this ever-growing list of this data. And specifically what they've done, so if you were to make a list like this, it would look something like this with your times, longitude, latitude, elevation. What they do and what's part of the CZML specification is to save space by plucking out that global start time, and then instead of having a time stamp along the way, it's a time step that is relative to the start time. So you save like 50% of the space right there. At Revel, I work with a lot of GPS data, and I've been thinking about ways to further save space. And you can imagine, you know, rather than having longitude, latitude numbers that are absolute, they could be sort of relating back to the previous time step to save some space as well. But I would recommend looking into CZML if you're working with large GPS data, as it's a much more efficient way of storing this. And also the nice thing is that if you do get your data into a list like this, you don't need to be a JavaScript developer to make something like this. You just upload it into Cesium's JavaScript tool, and it will put it on a map and create like a time slider for you and all of this nice stuff. I'm curious about ideas and feedback to make a tool like this more useful, or just sort of how we can communicate route options in general. One thing to note is that Google Maps API does not provide the transit dwell times, so it's not accurate showing like a subway car, for instance, stopping at individual stops. I only have the duration of the overall trip, so I'm sort of taking a shortcut and smoothing it along the path, which is not ideal. Visualizing other key factors that I mentioned, like emissions, the cost, also, you know, circling for parking time if it's a privately owned vehicle. Incorporating multimodal trips would be fantastic. My own sort of personal use case for the Revel mopeds in New York is to combine them with the subway. So it would be interesting if you could do trip chaining like that. And then, you know, customizing walking and cycling speeds would be interesting as well. So I would love to continue this conversation and hear ideas that you might have. And with that, I wanted to show a quick demo. Sorry about this, I'm having some trouble. Okay. So here is an example that I will run right now. Oops. Yeah. Oops. Okay, so here is the syntax for Wayfinder3D. It's on GitHub, and I have some instructions, but what you need to do is say Python run.py, and here are the main arguments that it takes So you can type out the origin in just, plain English and destination, and Google will do that sort of language processing for you. And then you select the modes that you want to see. And driving, transit, bicycling, and walking are the 4 modes that Google Maps offers. So what I will do here is an example. I'll zoom in if I can. So this was a trip that I made last night from Washington Circle in DC to that restaurant, Busboys and Poets, which I love. And I'm going to say driving and cycling for the modes. Transit loses big time here, so I'll show that one also, but I want to show a good one first. Oh, whoops. All right, just a second. Okay. It's bicycling. Okay, so it has generated the application. You copy and paste this address into your browser, and you are presented with this map. So all of this stuff, like this sort of time bar and like the speed slider, looks like they tie right now. Interesting. All of this is sort of provided by Cesium. You can click on a particular mode and track it. Looks like something weird's going on here. Why are they the same exact time? I'm going to pull this one up instead. So you can click on one mode and sort of like stick the camera to that mode and see as they move along. Cesium has a bunch of different base maps, so if you want street labels, you can do that. They have some pretty funny ones as well. If you wanted like a watercolor map, you can do that. They have this the NASA like black marble image, which is not so useful here. But so I use this essentially as like pro-cycling and transit propaganda and send it to friends and family. So you are welcome to do the same if you'd like, or to use it for other purposes. I guess I'll pause there and open up. Yeah, 1 minute left, so. Yeah, I'll stop there, thank you.
Did you have other projects you wanted to share? Or?
I mean, I have my transit flow project from yesterday that I shared to people. It looks like a number of faces in this group, so I don't know if that would be good to do again.
So obviously people are welcome to go to other panels if you want, but I'm going to stay here. So any questions for Will? Because the 2 other speakers are still not here. So.
Hey.
So my question is, well, I would guess that the Google Maps API for driving is fairly okay, but I wouldn't be that sure for other kind of like, for bicycling, for example. Generally the bike paths or bike lanes are not very good represented in any maps. So I wonder if you could like, first, I don't know if any of the Strava, for example, or any of those kind of apps have like APIs to get some of like the data from them to do these kind of things. And the second would be, well, for the thing of like the dwell times of the buses, if you could use like a GTFS real time or something like that.
Yeah, I mean, I don't know much about how Google does bicycle routing. I have no reason to believe it's worse or better than other alternatives. The transit is definitely a problem, though, because they don't take into account, real-time delays and congestion. So, if anything, it may be making the transit look better than it actually is. So, I don't really have ideas around improving the cycling directions, but certainly for dwell times, if I or someone else who wanted to contribute to the project was willing to put in some work to incorporate realistic dwell times, I think that would make the tool a lot better, definitely.
So for dwell times, what I found when I was looking at TTFS data from WMATA, their arrival and departure times are exactly the same. So I suspect a lot of transportation companies are doing that. So it's not Google's fault, but they're just displaying the data that they get from transit agencies.
Yeah, that's true.
And they just don't, I mean, transit agencies struggle really with how to put out their TTFS. But I suspect the Google directions API, you know, if he's using the API to say, just show me what a typical user would do.
Yeah.
So that's not even going to query in real time, it's going to query the standard.
That's really helpful.
Yeah. Yep. Yeah, I mean, what I wanted to do here was to provide like inspiration around this metaphor of like a race and maybe some additional data laid on top of that. So I would, if someone took that idea and was to build out a more robust application, like I would be thrilled to see that.
Weekend is an open source library.
Yeah, open source JavaScript library for time dynamic 3D globe.
The basic method using this is coming from where?
They have a number of different providers. This is from Bing Maps. You know, I could do Mapbox, streets, colors.
Do you have licenses free?
Yeah, this is free. How they're dealing with the licensing requirements, I don't really know. You sign up for an API key through Cesium, and everything else is free. Yeah, some may charge, but I haven't paid a dime for anything in this project, and it's working okay for me. So yeah, I'm not totally sure how they deal with that. Mm-hmm.
I think for commercial usage, we probably have to read the licensing on the Cesium product to be able to understand if it could be supported for, you know, free usage even for a commercial product.
Yep.
All right, well, thank you very much.
Yeah, thank you, everyone.
Everyone.